I've been watching quite a few videos about monocycles recently. This is a bicycle or motorcycle but with one large wheel with its rider and engine inside. Monocycles look pretty challenging to ride, mainly because they're unstable in all directions, although they will of course stand up on edge when moving at speed just like any other two-wheel motor vehicle or a coin rolled on its edge. The main issue is starting and stopping because inertia plays a large part since the wheel can keep rolling over and over. So I thought I'd make a radio control version of a monocycle and see if we can add some dynamic control to it to make it easier to drive. Just a quick ad from my 3D printing sponsor. Thanks to Lolsbot for supporting my channel with 3D printers. Thanks to 3D Fuel for the filament for this project and lots of other projects, so check out my channel for more 3D printing projects and check out 3dfuel.com. I've made a big wheel which has got a TPU tyre attached so we get lots of grip, and that screws on all the way around. It's pretty tight, I haven't really left any tolerance there, but the TPU is slightly stretchy, so I'm just stretching it on and I've got screws there. I haven't put all the screws in the holes, we've got one in roughly every other hole, but that seems to make a satisfactory wheel for our monocycle that rolls along by itself. But we need to add a motor so that we can power it, so I'm using one of the 6-volt motors which I got from Robotics, and this motor is the same as the motors I used in a video from a couple of weeks ago for my omni-swerving robot that can drive in various different modes. I'm using a gear to drive on the inside of the big wheel, and that's just got a grub screw to attach to the motor, and it's roughly the same size as the wheels from the other robot. It's quite important this goes fast enough that it'll stand on one edge. Now I 3D printed these gears of course, and they seem to interlock just fine, but only in one direction. So now I've added some bearings and a couple of supports there, so that we can actually lock that wheel in side to side and it won't slide out. And you'll notice I've put those bearings at an angle so the whole thing can lean over to steer and the bearings don't catch on the ground. I've repeated that arrangement in 2 other places at the top, and I've just got some idlers there which are again gears that lock into that outer wheel and 2 bearings on each one so that the whole mechanism stays in the middle. So that seems to align pretty well, and it runs pretty freely and keeps everything aligned. I'm using a standard 2.4 GHz radio set in the name of reliability and range for this project rather than my other universal remote. I'm actually reading the signal out of the receiver with an Arduino there, and then that drives the motor via a very overpowered motor driver which is a BTS 7960 rated about 40 amps. I am overdriving the motor though, it's a 6-volt motor, and I'm driving on a 12-volt LiPo, so I've got a battery eliminator circuit there as well to give me 5 volts for everything else. It's slightly off balance, you'll notice it tends to fall to the side with the battery on, but we'll see how that goes for us. Hopefully it'll stay upright if it goes fast enough, so that shouldn't make too much difference. Well, the motor and the idlers and ultimately the big wheel on the outside seem to run freely enough. There's a bit of a kick when you start and stop and reverse direction, but I suppose we should put it on the floor and try it. There seems to be a bit of a pull to one side still, but in actual fact it seems to be the room, because if I ride it the other way then it still pulls to the same side of the room, so I think the floor might be ever so slightly sloped in that direction. One thing you'll notice is that the internals don't stay flat. You can see that the middle pitches up here and then pitches down again once the inertia catches up. And you can see that on pretty much every test run if you look really carefully. It starts pitching up, pitches down, and then it pitches up again right at the end before it runs out of space to run. We've seen this sort of problem before though. This is one of my BB-8 builds from some time ago. I went on to make one with side-to-side stabilisation, but in this one you can see that it just reels around like a drunken sailor. And you can see as it starts and stops, and as the velocity increases and decreases of the hub in the middle, that basically that causes it to rock. We solved this though by measuring that angle with an inertial measurement unit and using a controller to drive the actual angle, so we're driving the motor speed and keeping that angle at as near constant angle as we can. And that's actually radio controlled, so my stick on the remote is deciding which angle to keep the internals to, and the controller is controlling the motor to maintain that angle based on the angle of the actual internals, and that makes the whole thing much more stable. So now we can see that inertia doesn't build up as it drives along, because it's actually controlling an angle and varying the motor speeds and positions up to 100 times a second to maintain the angle. So I've added an MPU 6050, which is the Adafruit version of that board, and now we can read the angle of the pitch of the whole robot as we tilt it, and use that data to control the motor speeds to try and maintain the angle. So now we can see as we power up, if I tilt up too far then the motor slows down, and that causes it hopefully to not oscillate. The other thing we should be doing is speeding up the motor as we pitch down so that it makes the internals pick up again. Unfortunately we don't have any overhead because that motor's already running as fast as it can. I've also added some ballast in the form of 2 bits of M8 studding on one side so we can try and even it up left to right. Well, it still pulls to the same side of the room, which we'll look at in a moment, but you should be able to see that that platform in the middle stays at one constant angle for the majority of its run. So it looks like it's time to add some steering. I've added an additional radio control servo here, which is going to move some ballast left to right. And that looks like this. There's a big 3D printed assembly with plenty more space to attach some more ballast, but for now I've got 2 bits of M8 studding, and lots of washers and nuts lined up there to add some mass, and I've tried to keep that as low as I can. That was pretty dreadful to drive, and the mass didn't seem to make much difference, so I've added a bit more ballast and we'll see how that goes. Well, we're getting there, and there's at least one run you can see that actually it veers off to one side, and then I steer it and you can see it leaning and actually steering in that direction, so I'm feeling pretty hopeful. I decided to spirit level the ground, and you can see it does in fact lean over to the right hand side, which is probably why it always drives into that wall. The other problem is oversteering, which causes the motor to catch on the ground, which is why it seems to trip over itself sometimes before it reaches the end of the run. So I decided we could use the data from the roll axis of the inertial measurement unit, which measures the angle side to side, and you should see that tend to 0 in the middle and swing as I move it. And that means we can make more of a dynamic system, which actually auto-compensates and tries to keep the whole monocycle at 0 degrees. So you can see that it's compensating with the pendulum there to try and steer it in the opposite direction. I can still modify that angle with the remote though, so I can steer in one direction, setting the angle, and then hopefully the inertial measurement unit and the controller should try and maintain that angle. So now it's running in a big open space with nothing to crash into. It's actually pretty good, and it's not too hard to drive. You can see the steering's a bit delayed though, but I can still control it relatively accurately, and it's pretty easy to hit targets if I want to. Sometimes there's a bit of wobble sometimes, especially when it heads downhill like here towards the camera. Sometimes it'll pull through and other times it'll crash. And you can see that side to side axis trying to compensate all the time. I think perhaps the gain's a bit too high and I really need to turn it down. Sometimes it looks like it's going fine and then there's a crash and it looks like the side to side axis overcompensates, causing it to wobble. Other times it seems there's no reason at all. Majority of the time though, it runs okay, so I think I'm pretty happy with that. On closer inspection though, it appeared the battery balance connector had probably got caught in the geared track at some point, which may explain the random trips, and the rest of the battery's not looking too good either. I would have reprogrammed the side to side activity, but the Arduino USB connector also got mashed and it wouldn't program anymore. So I'm pretty happy with how that drives. I think having those active controllers, at least in the front to back axis, really helped to keep it stable. I think side to side we need to turn the gain down so it doesn't oscillate so much, or actually just put it back to manual mode so it's just controlled by the stick on the radio controller and it doesn't try to automatically compensate. I think because it's like a coin spinning on its edge, it probably stands up anyway, and that will be perfectly good for the steering. Unfortunately, that Arduino Nano connector's completely smashed and it won't program again, and it's soldered down to the board. So I'd have to rebuild the electronics to try it, but I have a feeling that would work. I'd also really like to try stabilising it with active gyroscopes like my 2-wheel inline balancing robot and my 1-wheel balancing robot, and that means we could just stand stationary on the spot and have active control, and it wouldn't rely on being moving to keep it standing on one edge. But I'm going to publish all the CAD and code for this as I usually do, and you can find that link in the description to this video on my GitHub. So if you'd like to support me through Patreon or YouTube channel membership, you can find those links in the description as well. And YouTube channel memberships and patrons get access to all my videos up to a week early and sneak peeks and pictures of what's coming up, so you can be part of that discussion. Alright, that's all for now.